Hello friends, today we're going to look at evaluating logarithms. Hope all is well. It is a chilly April day out here and stuck inside yet again and again and again. When are we going to get out of here? Who knows? I hope everybody is well. Going to go through evaluating logarithms. So yesterday we had looked at switching between exponential and logarithmic form, and we're going to take advantage of that today, but also thinking about what it means to evaluate a logarithm. So I'm going to go over to my notes, and you should of course be taking your own notes, following along with some examples, making notes for yourself. That's how this works. Not just do the practice. Please watch the video. Is anybody watching the video? Hours and hours I spend here talking to myself. 3 views. Come on, give me a like or something. All right, switching over to the notes. So we're going to be looking at, get out of this actually, go to booth, go on. All right, we're going to be looking at evaluating logarithms. And the whole idea is that a logarithm goes and finds an exponent. Logarithmic statements are the inverse of exponential statements. The logarithm finds the exponent. It's all about trying to find the value of an exponent that makes a statement true. So, for example, if we have log base 2 of 32, think about this. There's our base, log base 2 of 32. What that means to us, and you can read it, what that means to us is it's saying 2 to what exponent gives us 32. So a lot of this math, it's all about how we can interpret the symbols, what the symbols mean to us, how do they guide our thinking. Anytime we see log, it's saying the base to what exponent gives us the argument, the value inside the logarithm. So 2 to what power gives us 32? Well, we rack our brains a little bit, think about 2, 4, 8, 16, 32. Okay, that's 5 times we've multiplied by 2. We could switch this into exponential form and say 2 to some power is 32, but that's the same thing. If we see log and it tells us this is how you think, well, we're switching forms in our head already. That's how we're thinking about it. So 2 to what exponent is 32? We, of course, know that that would be 5. I want to clear out what I've got in my calculator over there. Need that for later. Oops. Sometimes it does help to switch between exponential and logarithmic forms. Where am I? Nope, wrong calculator. All right, if we have log base 3 of 9, well, we really shouldn't need to switch forms for that. We're saying 3 to what exponent gives us 9? Well, 3 squared is obviously 9, so log base 3 of 9 is 2. We shouldn't switch. If you need to, just to get an idea behind it, go for it. Other times it does help. Log base 8 of 32, that's saying 8 to what exponent is 32. Well, if I take 8 multiplied by 8, that's 64. That's somewhere in between 1 and 2. So how do we get there? It's not as clear. Switching to exponential form, we have 8 to the x is 32. Here we can think about this. Back to what we did yesterday where we were solving exponential equations. Is there a common base between 8 and 32? Well, we could rewrite this. 8 is the same as 2 cubed. We have 2 to the third to the x. And then 32 is 2 to the fifth. Using our properties of exponents, power of a power, that's 2 to the 3x equals 2 to the 5. And now since we have the same base, that implies that our exponents are equal. 3x equals 5, and x is 5/3. Not as clear as if we were just saying, back to the beginning, log base 8 of 32, well, I'm not that good. I'm going to switch to exponential form and find a common base. So I've got x equals 5/3. Going on, another example, log of 10,000. Well, uh-oh, log base what? Now, common notation, this is called the common logarithm. When we have no base, when no number is written there, that implies that it is base 10. So if we take log 10,000, switch from exponential into exponential form, that gives us 10 to some exponent is 10,000, and of course, that value, that exponent, would be 4. Sometimes there is no clear evaluation. If we have log base 3 of 32, if we switch that to exponential form, we've got 3 to the x equals 32. Well, 3 times 3 is 9 times 3 is 27. 32 and 3 do not share a common base. Switching to exponential form does not really help us out. How do we solve an exponential equation? Well, we would use a logarithm. So we would switch back to logarithmic form. We need to evaluate this statement, log base 3 of 32. That's where the calculator comes into play. So evaluating logarithms, I'm going to be going over the calculator now. Under the Math button, if we scroll down, we'll eventually see, under Math, log base. Log base, this is where we can evaluate in the calculator. I'm just going to enter log 3 of 32, and we get an approximation. So 3 to the 3.15464 blah, 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 gets us 32. It is an irrational number because there is no common base between the two of them, between 3 and 32. So we can use the calculator to evaluate. If your calculator does not do this, if your calculator does not have that log base option, we would need to use something called the change of base formula. We'll get into that a little bit later, but in short, we would just do log, using the log button, 32 divided by log 3. Log of the argument, the value inside the logarithm, divided by log of the base. That would give us the same thing. Now, another note, in the calculator, we've got the log base option under Math. We have log, that's log base 10, and then there's also ln. ln is natural log, that is log base e. Anytime we see the number e, the number e, we would use natural log. We've got some projects for you up on Google Classroom. Let me know if there's any questions. It's all about evaluating logarithms. So think about what the log means. Going all the way back to the beginning, it's saying 2 to what exponent gives us 32, or the base to what exponent gives us that argument. So think about it. Think about what the math means for each of us and how we can interpret those statements. Good luck. Let me know what you have. Stay safe.